So I must say, I'm honored to be here with all of you and to be part of ELISA family. Yeah, I mean, some of you have spent really decades on this, me only for 6 months, and that's why I'm super pleased to be here with you. So I will not talk about the past because it doesn't belong to me, but I understand this is a journey that started 50 years ago, as Nora just said, and with the launch of a Pathfinder in 2015. But what happened then in 2024 is the adoption. So I must admit that when we decided to do this talk, I asked myself, oh, what can I talk about? I don't know anything about LISA. They know science much better than me. They know all the measurement principles much better than me. And something that a project manager would do in such a symposium, presenting the spacecraft, pictures of what we are doing, I cannot do because we have nothing. So I said, okay. I said, maybe the only sensible thing I can try doing here is to give you a flavor of how LISA is seen by the agency nowadays. And this I have witnessed in the last 6 months, because I started in July, August 2023, and I spent 6 months of my time preparing for the adoption. And as brilliantly said and nicely said by Carsten yesterday, this is a big thing for the agency, and some decisions that have been made were not obvious at all. So for the agency, spending such an amount of money for one single mission was not obvious at all. We had never done it before, at least for a scientific mission like this one. For operational missions like the Galileo, maybe yes, but not for a scientific mission. So, and when I, as a project manager, tried to put forward my needs, how I wanted to organize the team, how I wanted to do things, I must say that I received positive feedback. So that is, this talk is to say that, and we ended up with a team which is an outlier with respect to the business model we have now at the agencies. So this is something I wanted to tell you. So we are currently 26 people, 27. At regime, there will be more than 30 people in my team. Then we have many colleagues from the technical directorate that will be supporting us. We have people in Villafranca doing the science operations, as Nora said. We have people in Darmstadt for the normal operations. So it's a big team, much bigger than we normally have at the agency. Why that? Because LISA is perceived as the flagship mission of the agency. Its technical complexities, the technical challenges, the programmatic challenges are acknowledged, and that's why something like that was possible. Now, quantity is not a synonymous of quality, I understand, I appreciate. So, but at least, so we have to prove that being a robust team, we can do it right. But certainly, I think I can talk on behalf of all the colleagues of mine. We are all super determined to do it right. And to be here in 2035 to give you the spacecraft, you need to do science, because that's the only thing we need to do, give you the best spacecraft we can build. Now, Nora didn't mention this. I suppose most of you obviously know this one, but just to set the scene before I tell you the few things I can tell you about the spacecraft. So you know that we have these 3 spacecraft in constellation at 2.5 million kilometers with an inclination of 60 degrees. With respect to the ecliptic, we are trailing or leading the Earth. This decision will not be made now. It will be made much later, and it depends on the number of things we have to consider, including the need of using the ground station of 35 meters, so which we will have to share with other projects. And the decision whether we trail or we lead may depend on that one as well. Instead, oops.
Switched off.
It's off? Oh, this one. Instead, we have made recently a decision, which is not a difficult one, not a complex one, but I just wanted to mention this. We had to decide whether to rotate clockwise or counterclockwise with respect to the sun. A decision has been made to be clockwise with respect to the sun, and this decision was necessary because we had to freeze the design of a PAM, the point-ahead mechanism, so we had to make a decision whether to go this way or that way. This we have made recently, and this is our configuration. Now, in terms of phases, we will have, after the pre-launch, we will have a transfer after a near-Earth commissioning of 1.5 years. Then the true commissioning, which is the acquisition of the constellation once we get in position, of 3 months. And then the nominal science phase of 4.5 years and 1 week of disposal. This is to say that the nominal mission is 6.25 years. However, we will embark, obviously, consumables for extending it as much as we can, up to 6 years. So we will do, obviously, we will take on board what we need to take on board to extend it if circumstances allow. Now, the 3 spacecraft will be 3 identical spacecraft, each of them with a capacity of about 2.3 kilowatts for the science mode, and with a bus of 28 volts. The mass of the overall thing is about 1.3 tons, out of which 2.4 tons per spacecraft. And then, of course, you have to put the adapters that you need for the configuration on the launcher and the propellant. Communication will be via the 35 meters dish we have as part of our ESA track, our infrastructures. We have 270 kilobits per second data rate, and we will have an 8-hour pass per day. We will be using an X-band antenna, which is enough for the ESA needs. Our transfer instead will be done with electric propulsion. We have some heritage here, and we will have with xenon thrusters. They will be used only to get there, to get where we need to be, and then this electric propulsion will no longer be used. Instead, an important element of the LISA constellation is the drag-free and altitude control, which has been tested already in the Pathfinder. So we will use exactly the same thruster, the same cold gas thruster by Leonardo, nitrogen thruster. These are micronewton thrusters, and we have obviously strong heritage here because we have flown them on the Pathfinder, on Gaia, and recently on Euclid and on some other missions. Now, I said at the beginning, and this was also mentioned by that LISA is quite complex from a technical but also from a programmatic point of view. Oliver said something very interesting yesterday. He said that this is not something we can do that one single entity can do alone. So it's a true partnership. We do this, as you all know, in partnership with NASA. NASA is providing vital elements for the LISA mission. They provide the telescope, the lasers, and the charge management device, and of course they have their own ground segment. And then we have contributions from several member states for the payload element. So at ESA, we retain the responsibility of the space segment, the ground segment that we do by our colleagues in Villafranca, and then the launch segment. On Tuesday, we will know whether we have a launcher for LISA in 2035. Remember, there is the first Ariane 6 launch. So our prime will take responsibility of the platform elements that you see there. Do you think I can, this one? Oh, this? Red one. Oops. No. Okay, this one. So our prime will be responsible of all the platform. We'll take also some responsibility for the payload because they will be in charge of a co-assembly of LISA, where we have a MOSA and the OETM. So the OETM is the mechanism to compensate the breathing angle, the breathing of the angle. And then we have, on the MOSA, we will have to mount all the elements that are provided by member states, the IDS, led by DLR, the GRS, led by ASI, SDS, which is spread across the spacecraft by the Spanish, and then we have a telescope and the laser. The OTS are the facilities for testing the payload. So as you see here,
This is a true cooperation. LISA has formally the responsibility of the system activities of a payload, hence the need to have a large team. So differently from how the Pathfinder was done, for instance, where the prime had the responsibility of everything, here we retain the responsibility of a payload integration, of a verification, and the performances of the entire constellation, and hence the need to have a team of Martin at ESA. So, and that's why, and Martin will tell you about what we plan to do for those activities. Now, just to give you a flavor of how the spread is, this is a nice chapter, slide, which I think is also on the Red Book, if I'm not mistaken. I can't recall, but anyway. So here you have a bit an idea of who does what in the consortium. All the countries that contribute to, as with CFIs to the payload. Now, to conclude, I think the last thing I wanted to tell you is what we will be doing in the next month, let's say one time scale of 1 year, just to give you, so that maybe you know what you can expect from now until mid of 2025. So we have released on time the ITT for the selection of a prime on the 28th of March. This was done absolutely as planned. Then we will receive the proposals from the 2 primes on the 2nd of August. We will spend the 3 months, August, September, October, for the selection. End of October, we have our TEB, and we will then make a recommendation to the Industrial Policy Committee and we will ask to be authorized to start negotiation with the prime. We aim at starting the negotiation with the selected prime end of December, January the latest. Ideally, I would like to send the letter to them by mid-December and December so that they can prepare for the negotiation. At the beginning of 2025, we plan to spend 4 intense months of co-engineering with the prime and with all the payload teams to resolve as much as we can all the interfaces, all the open points that we have for the interfaces, which obviously we do have, because the 2 designs that we will receive in August are completely different. So we couldn't freeze all the interfaces. This should last until April. Meanwhile, in parallel, we aim at doing a couple of system reviews for the IDS and the GRS. And we hope to have completed the PDRs, the preliminary design reviews of these subsystems, the 2 major ones, by Q1 2025. In parallel, NASA is advancing with their own review cycles. We discussed this morning about an SRR that was done on the telescope. And so the 2 things should be in phase, should progress in phase. And by Q1 2025, we should have, let's say, a consolidated design and discuss with the prime. Then we will have our major corporate review in Q3 2025, a system requirement review, where we will review as a whole the full constellation with the prime requirements, our CFI requirements, the preliminary design we have. And this is something that we aim at doing in Q3 2025. I think I kept it short. Good. So I think I leave it to Martin now, and he will tell you about the mission, performances, and what.
Yeah. Thanks a lot, Filippo. Good morning, everybody. Amazing to see so many people, some of whom I know and many I don't, which is a surprise and really cool. Filippo mentioned many parts of the team there, and clearly you'll hear many things throughout this week from the people involved, especially in the hardware. And when we were discussing what to do here, the one aspect that was not clearly well represented throughout the week in any concise way, and what we think will be important for many of you, was the performance and operations. So I'll say a few words on this and who those people are. For some of you who are not maybe so familiar with LISA over the years, I just wanted to introduce this topic with a few key points about the measurement principle and why this then flows into some of the strategy we've taken with respect to performance. So we're aiming to to do this measurement of gravitational wave strain. That for us means measuring basically fluctuations in the distance between geodesic reference test masses. Those test masses then need to be shielded in order for them to remain as geodesic as we can, need to be shielded from any perturbing forces, so we place them in spacecraft. This little cartoon I'm building up for a reason in a moment, and you'll see that. And we need to measure then the relative motion of the test masses, which means then we need to do a 3-part measurement across this track here, okay? Now, we also need to do that across different arms, so we end up with a constellation like we have, and you can already see very quickly that we combine then many, many measurements across the entire constellation in something we call time delay interferometry, with some additional post-processing steps that motivates many of the things we're doing in terms of the performance management in order to then finally produce the science observables, which leads to all the great science, or should lead to all the great science that Nora was discussing before. So if we start again from these science observables and go backwards now, that's how LISA is envisaged to work. That's the architecture we've set up. The question is, how do we then make sure we can deliver that? Now, at the moment, our top-level science requirements are translated into a mission implementation, and a mission requirements document captures that implementation in terms of top-level requirements, and our science observables are really anchored there, okay? So that we have to now design a system and flow down all the requirements for this to meet this final performance. And we do that through a series of different budgets, effectively. We have budgets that's mostly related to how all the system will be put together, and we have many of those. We have a lot of justification for why we do things the way we do, and we have to document those and argue against those in the future. And we have then a performance budget, which brings, from the perspective of performance and science observables, that brings that all together then to control the final performance. And out of this overall justification part, we end up with a ton of requirements that then goes into a real implementation of the mission, on the payload requirements, all the spacecraft requirements, things that we need to do in mission operations, and things we need to do in science operations. And all of that has to work together to deliver the science observables. And the way we've chosen to do that, and you don't need to go through this in too much detail, I'm just giving the flavor of the structure we've taken. There's many ways you can cut this cake up. We've chosen, for various reasons, to do it this way. We group things under optical metrology noises. We group things under the residual freefall noise of the test masses, and then we group things that are residuals due to the post-processing, any residual coupling mechanisms, of which there are quite a number, we categorize there. And really, that leads us quite naturally to a set of requirements mapping well to the responsibilities of the implementation. So just an example for the freefall, for example, I picked this one. I could have picked any in principle, but we start at the top with a requirement on the single test mass freefall, and we break that down into a number of different noise sources, a number of different physical effects that we can then categorize and manage in different ways. And it turns out there's quite a natural split of also the responsibilities with respect to these different noise sources. Each of those we then break down, of course, further, and we keep going in this process until in the end we arrive at a lot of requirements that we can set on a particular stakeholder in the mission. It could be, for example, on the GRS team for the hardware they have to deliver. It can also be on the prime contractor for elements of the spacecraft that they have to deliver. And then in the end, if we do our job right, and we hope we do, of course, we end up with an overall mission performance in this area that's categorized by all of those different effects. But underneath each of those lines, of course, is many, many other subterms that have to be managed, and all of the low-level requirements that have to be managed, and there are many. So what does that look like pictorially? Well, in fact, we start with all of these different budgets that I talked about, and some of them are interrelated, and many of you have been working with us over the last months to put this all together. All of those different budgets effectively flow into a performance budget. We have something like 700 entries in these budgets at the moment that we're tracking, and that number will likely increase as we go through the next few months. They're linked by over 28 different budgets, and all of those then flow out into a large set of requirements documents that many of you will have seen already. And then we go the other way up, of course, and in fact, it doesn't practically work like this. We go round and round in circles. But in fact, then we have a performance model that we use to check all of this. So we model bottom up with something like 375 or so different nodes. This number's changing, not on a daily basis, but we're still in a phase where this is changing now. And we have a lot of parameters as well that link into this model. And some of those parameters are in fact constrained by requirements as well on the different hardware elements. And then all that's put together in a structure, a software structure that lets us do this performance analysis and close the loop here to refine the budgets as we go over the next period and through the reviews. So who's doing everything? Well, there's the little performance team at ESA, but of course, there's no way this small team, although there are two very talented colleagues sitting in the audience here, Michaela and Eric, who you can talk to throughout this week. Nevertheless, we need a large team, and that's where the extension of the ESA team needs to start to bring in all of you. And we already have quite a number of your scientific institutes related to the hardware, related to mission performance, related to constellation and TDI and things like this, already involved in this team, and together we put that all together to form the LISA Performance and Operations team. And I realized after all these slides, if any of you are triggered by the color red, I think you're going to have a bad week. So already Nora's slides were pretty red heavy, and mine are also getting red now. So. Okay, so that's the team. They're going to be doing various things over the next years. They work with as many people as they need to get things done. We work with the operations teams, we work with the payload team, with the spacecraft team, with the science ground segment teams, and with all of the payload CFI teams, of course, to get this all working and bring it all together. And we do various things. We look at budgets, we look at the whole performance verification chain, how is this going to work? We track all the requirements related to performance, we'll go through and support all the mission reviews, and we'll start to support preparing all the commissioning and the science operations over the next period of years. And one of the kind of things, just to give a little flavor, is we will, of course, by tracking all of these parameters and by building up this large system of interconnected performances, we'll be able to track how the best and worst case LISA looks like, and we do this also statistically and play around with all the parameters. And as we go through and build up, remember we're building many of each element. As we build those things up, we'll be able to feed in real measured performances into this model and flow up and see where we are. Okay, so just a few closing remarks. We will move towards a review towards the end of this year, and thankfully, thanks to Stefano for agreeing to co-chair this review panel for us. We wanted to go into the co-engineering phase that Filippo mentioned on a fairly solid footing with respect to the performance budget and the requirement flow down. So we'll set this review at the end of this year, which is going to be a challenge for us and many of you who are involved in it, but we think it's important. And then as part of that, we'll start to evaluate, start to put in place a verification and validation plan, things like risk management and configuration control and all of these things. And then over the coming years, we'll go through the various mission phases, focusing on various aspects. It'll probably be a lot of budget refinement in the early years. And then as the development continues, we'll have to address performance and any non-conformances or other things as they appear. And I think I'll leave it there because we've used most of our time, but we want some time for questions. Thank you.
Thank you very much. Now is your chance, because we have 5 minutes left for questions that you always wanted to ask. Please go ahead.
Stunned silence.
Please.
I've seen lots of numbers, but I haven't seen any numbers with the units of euros. I'm just curious.
One
That's
of you.
yours. That's yours.
Ask again exactly what you need to know.
Euros.
Per year, per project, whatever.
Integrated over everyone.
I think integrated over the entire mission lifetime, putting everything together, member states, NASA, ourselves, it's a 3 billion mission. That's the best thing I can say.
That's exactly what I expected he would say. Anything else? Go ahead. Here. There's a microphone.
I have
you
a
have
question to Martin. Hi. So in performance, does it vary in the level or it also varies in the shape?
Yes, both.
Okay.
Is it enough of an answer?
Maybe to say something a bit more. So obviously when we're setting the budgets, we try to account for our current best knowledge in doing that, but as we start to build things, we will get reality check against whether we've modeled things in the right way. And therefore, there will be, in terms of the predicted performance, there will be an evolution over the next years where it will vary in both shape and in level, for sure.
Please, go ahead.
Question for Filippo. Did I understand? Yeah, hi, Karsten. Did I understand correctly? You mentioned emission extension up to 6 years in terms of consumables beyond the.
I think we can reach up to.
Can you go to the mic?
I think we will put consumables for up to 5-6 years more than the nominal lifetime.
5-6 years more.
Yes.
Okay. No, sorry. No, that was
an extension by. So no.
Okay.
On top of what you have seen, you put 5-6 years more.
Okay. No. Yeah. So sorry, it wasn't clear.
Thank you very much. We're exactly on time in our schedule. And I would say thank you very much for this official statement of a LISA consortium. And I think it'll stay like that for the next 10 years. Thank you.